let's talk about average rates of change. But before we go any further, let's define what that actually is. An average rate of change is a slope. And the slope is really going to be an average rate of change between 2 points. So the slope between 2 points, which really is slope anyway, but I want to put it in a more specific context, because if we're really going to talk about slope, then we really need to talk about this. Slope is second y minus first y over second x minus first x. Now, to be honest with you and clear with you, I almost said to be obvious, we could reverse the order of these and have y1 minus y2 and x1 minus x2. Totally fine. But don't reverse the numerator without reversing the denominator. You'll get a sign error. Okay, so we're going to find the average rate of change for this function and for this function on the following intervals. And it's going to be from 0 to 1, 1 to 2, 2 to 3, negative 1 to 1. That's going to be the odd one out because there's a pattern to these first three. So let's start by going from 0 to 1. And I want to show you what we're really going to do. Okay, so I know I just sort of defined things vaguely and moved on. We're going to go from 0 to 1, x values. So from 0 to 1, and I want to find the slope from 0 to 1 right here. So that's what this is. From 0 to 1. And I want to know what the slope of that is. Now, let's just be real honest. Since the x-axis is on a scale of 1 and the y-axis is on a scale of 1, we could just simply go, oh, slope, rise over run. Rise 1, run 1. The answer is 1. I know it's 1. You know it's 1. I'm happy. You're happy. We go home, right? You're fine. You're right. But let's do it. Actually, do it. Do it. So this is the slope between the coordinate 0 comma something and 1 comma something. And that something is, okay, well, 0, negative 2. There's that one. And then 1, negative 1 is that one. And if we didn't even know those numbers, what we could do is plug them into this function. So they may not give us a graph that we could really easily identify things with. We would really need to plug it into the function and figure it out. Or they might give us a table of values, which does happen on the back side of these notes. So keeping that in mind, we have x1, y1, x2, y2. If this seems a little excessive and you're like, the slope is 1, you've already told me. I hear you. Just hang with me. Hang with me for just a second. So we're going to go y2 minus y1 over x2 minus x1. We're finding the slope between those two things. And that's going to give me, I just wanted to write the formula in red. It's just important to me. Negative 1 minus negative 2. Yeah, you see it also, don't you? 1 minus 0. That's going to give us plus a positive, so 1 over 1, which of course is 1. Wow, I'm so surprised. And so are you. All right, notice this one's a parabola, and this one is exponential, and we can tell that from the equations as well. Let's do the same thing here. On the interval from 0 to 1, so at 0, dot, at 1, dot, and we're going to connect them. There we go. And I want to know the slope here. Now, I could go through the same stuff, love to do the same work, and you'd be like, oh my goodness, I get it already. I can see the slope is 1. They have equal slopes, equal average rates of change on the interval from 0 to 1, okay? So, love to show the work, not gonna do it. I think we got it, right? So feel free to show everything you wanted to show. I'm gonna show a little bit just so I can put it in context. This coordinate is at 1, 2. So it's gonna be 2, 1, 1, 2. And this other coordinate is 0, 1. So 0, 1. There we go. And sure enough, that gives me 1 over 1, which is 1. All right, so let's move on. What we're going to do now is find the slope from an x value of 1 to an x value of 2 for the parabola and for the exponential. We're going to see where this is really going in terms of steepness over intervals. So from 1 to 2, let's find that slope there. Let's see, from 1 to 2. That's it right there. I want to know the slope of that line. And this line goes from here to here. Those are 2 points that we know for sure on that line. And we can rise 3 and run 1. And I think I am going to just really abbreviate it at this point. So we're going to rise 3 and run 1. That would be 3 over 1. So that's 3. All right, getting pretty steep, right? So as we go from 0 to 1, slope is 1. As we go from 1 to 2, the slope is 3. So let's come over here and do the same thing. We're going to go from 1 to 2. Okay. X value of 1, X value of 2. All right, slope here is rise 2, run 1. Okay, there we go. So they start out with equal slopes on the same interval, and then the quadratic overtakes the exponential, and then we'll see what happens. Okay, so we're going to go from 2 to 3 now, and as we go from 2 to 3, 2 to 3, and I want to know the slope of this one now. It's getting pretty steep on this side. So 1, 2, 3, 4, 5 over 1. Ah, okay. This reminds me of a previous lesson when we talked about parabolas that have not a constant slope, that would be a line, but the first difference is constant. Let me explain what I mean. As we go from 0 to 1, 1 to 2, 2 to 3, our slope is 1, then 3, then 5. But really, if we go one step further, we'd say, oh, well, the difference between these is 2, and the difference between these is also 2. So because that second difference is constant, this is quadratic. Okay, let's do the same thing here. We're going to go from 2 to 3. X value is 2, X value is 3. We're going to connect those. And we're going to have, let's see, 1, 2, 3, 4 over 1. So rise 4 over 1. This one is 4. Okay. Wonder what's going to happen next. So if this was not negative 1 to 1, like if this went from 3 to 4, I think we could very easily predict the next number here, and we could also predict the next number here. And we're going to realize pretty quickly that this one's doubling. So it's going to overtake this one. This one, the exponential, is going to get really steep really fast. They look kind of equivalent, and we see some similar-ish numbers here. But the exponential is going to get really steep really fast. Okay, now let's go from negative 1 to positive 1, and we're going to have this really bizarre average rate of change here where we go from negative 1 to positive 1. And I want to know what the slope of this line is, and I really hope that it just went right through your head and you kind of rolled your eyes and you're like, I know that. I know it too. So let's do it. And I do want to actually do it. So here are my coordinates. Negative 1 comma something and 1 comma something. And those somethings are the y values, which is negative 1 and negative 1. So stating the obvious, as we do y2 minus y1 over x2 minus, oops, that should be a negative. Yeah, that's right. As we do that, sorry. Slight brain fart for a second there. We're going to have 2 in the denominator, but the numerator is going to be 0, so we have a slope of 0. No one is surprised at that. That was a flat line. Okay. So as we do this one, we have a dot here, and I may not know exactly where that is. I'll go ahead and tell you actually it's at 1/2, but you may want to use the actual function itself to figure it out, and I think we will, just for fun. So I want to know the slope of this line. So let's find the slope of this line from x value of negative 1 to an x value of 1. And so we're going to plug in a negative 1, crank out a value, plug in a 1, crank out a value. That value is 2. When I plug in a negative 1 right here, I have 2 to the negative 1. So indeed it is 1/2. So 2 to the negative 1 is the same as 1/2. So 2 minus 1/2 over 1 minus negative 1. We'll just do it that way. Gives me a 2 in the denominator. That gives me a 1.5 in the numerator. We'll do that. And if you're like, that's a weird fraction, I have a decimal in my fraction. It's okay. Let's just double the numerator. That'll get rid of your fraction, right? If we double that numerator, we don't have to double that denominator. It's 3/4. It works.